Welcome to Module 1, Occurrence and Impact of Disasters. In this unit, we will focus on floods, one of the most common and destructive natural disasters. Together, we will explore how floods occur and the impact they have on communities and the environment. Let's begin. Participants will be able to identify flood-prone areas and understand the risks associated with flooding, including the use of monitoring systems. They will learn how to conduct rapid assessments in flood-affected regions, evaluate damage, and recognize potential hazards. Participants will also become familiar with debris removal and disposal procedures, as well as principles of water safety and sanitation. Additionally, they will be able to distinguish between different types and classifications of floods and explain the environmental, social, and economic impacts caused by flooding. A flood is typically defined as the overflow of water onto normally dry land. This can be caused by excessive rainfall, dam failure, or other contributing factors. Floods can be classified based on their magnitude, how frequently they occur, how long they last, and the size of the area they affect. Floods can occur due to a variety of causes. These include excessive surface runoff that exceeds drainage capacity, the deterioration or congestion of drainage systems, and deforestation, which reduces the land's ability to absorb water. Other contributing factors are rising sea levels due to wind, tidal effects, global climate change, and the unintended consequences of embankments constructed in other areas. Each of these factors can increase flood risks in vulnerable regions. Floods can be classified in various ways. By type, they may be river floods or coastal floods. By cause, they may result from heavy rainfall or from snow and glacial melting. Based on time, floods may occur in summer, winter, or spring. In terms of duration, we distinguish between flash floods and long-term floods. According to where they form, floods can happen in rivers, mountain areas, cities, or coastal zones. And finally, floods may be caused by natural factors, such as weather and geography, or by human activities. Floods can be classified into three main types: river floods, coastal floods, and flash floods. River floods are divided into two categories: upstream floods, which usually have a low flow speed, short duration and heavy rainfall, but they can result in significant loss of life. Downstream floods, on the other hand, last longer and involve high levels of precipitation over time. Coastal floods are caused by high tides or storm surges coming from the sea. Flash floods happen when rainfall exceeds the ground's absorption capacity, or when water flows quickly over surfaces like concrete. This leads to a sudden and dangerous rise in water levels. River floods occur when the volume of water exceeds the drainage capacity of rivers, streams, or creeks. While rainfall is the main cause, other factors play an important role. Some rainwater is absorbed by soil and vegetation, but the rest flows directly into rivers as runoff. River characteristics, such as size, shape, vegetation, and surrounding structures, also influence water levels. The more developed or paved a catchment area is, the more runoff it creates. Vegetation helps absorb rainfall, while high rainfall areas with little vegetation tend to increase surface flow. Storage systems, both natural and man-made like dams and tanks, help reduce runoff. Finally, factors like soil type, land use, and previous weather conditions affect how much rainwater is absorbed and how much becomes floodwater. This slide explains the factors affecting stream flow, which determine how much and how fast water moves through natural waterways after rainfall. Once water enters rivers or streams, several elements influence the downstream flow. Impervious surfaces, like roofs and roads, prevent absorption, leading to more runoff. Larger catchment areas result in greater stream flow during extended rainfall. Steep slopes in the terrain accelerate the movement of water. Vegetation, fences, and surface roughness slow down the flow, which can reduce flooding further downstream. Natural areas like ponds and swamps temporarily hold floodwater and release it slowly. Similarly, artificial structures such as dams and detention basins help manage flow but have limited storage capacity. The carrying capacity of drains, creeks, and rivers is influenced by various factors. River size and characteristics such as its width, shape, and smoothness affect how well it can carry water. Anything that reduces this capacity, like built structures, urban development, or sediment buildup, raises the risk of flooding. Vegetation in and around waterways slows down water movement. This can raise water levels locally, but helps reduce downstream flood impact. It also prevents erosion and supports sediment deposition. The nature of the adjacent floodplain is also important. Wide, flat floodplains can store more floodwater and slow its movement. Changes to these areas, like clearing vegetation or building embankments, may disrupt natural drainage. Man-made structures such as culverts and bridges can limit flow capacity, especially when debris collects around them. Finally, levees and embankments are built to protect areas from floods, but they can trap floodwaters and cause higher water levels upstream if not properly designed. A floodplain, or special flood hazard area, is an area of land adjacent to a water resource, such as a creek or river, that is prone to flooding. The floodplain can generally be broken down into two sections: the floodway and the 1% flood hazard area, formerly known as the 100-year floodplain. Coastal flooding refers to the occurrence of flooding in areas that are typically dry and located at a lower elevation, as they become inundated with seawater. This phenomenon arises due to a rise in sea level, causing the water to overflow onto the land. Now, let's test your understanding. Blank refers to the occurrence of flooding in areas that are typically dry and located at a lower elevation, as they become inundated with seawater. The correct answer is coastal flooding. Well done if you got it right. This slide explains how coastal flooding can transpire in the following way, through three main mechanisms. Direct flooding occurs when the land lies at a lower altitude than the sea level and there are no natural obstructions such as dunes to stop the waves from advancing onto the land. Water surpassing a barrier also happens under the same land conditions, but in this case the water level becomes high enough to overflow the barrier. Water breaching a barrier refers to situations where strong waves physically break through a barrier. This breach may damage or destroy the barrier, which could be either natural or artificial. There are numerous factors that can contribute to flooding occurring along or near the coastline. The primary causes encompass elevation of the land relative to sea level. Coastal flooding poses a significant threat to low-lying areas along the coast, as the ingress of seawater can readily extend inland. The megadeltas of Asia serve as a prime illustration of regions susceptible to coastal flooding. Erosion. Erosion refers to the process by which materials, such as earth or sand, are gradually worn away and transported to other locations through natural forces like waves or wind. This displacement of materials from their original position can lead to the weakening or complete removal of the affected area. Subsidence. Subsidence occurs when underground substances shift, causing the ground to sink. This can be a consequence of natural factors like earthquakes or erosion, as well as human activities such as mining mineral resources or extracting natural gas. Coastlines situated at low elevations are naturally susceptible to subsidence due to the settling and compaction of recently deposited sediment. Removal of vegetation. Coastal vegetation, which includes trees and other plants, plays a crucial role in regulating the movement of rainfall. It acts as a barrier, intercepting rainfall and slowing down its flow. Some of the intercepted water is stored within the vegetation, while the rest evaporates back into the atmosphere. Furthermore, the vegetation facilitates the absorption of water by the soil, allowing for greater infiltration and reducing surface runoff. Storm surges. The occurrence of storm surges is a significant cause of coastal flooding. Storm surges are temporary elevations in sea levels, resulting from events like tsunamis and cyclones. A storm surge is measured by the water level exceeding the normal tidal level, disregarding the presence of waves. It is known that global warming is causing a rise in sea levels, but it is important to understand the implications of this rise in relation to coastal flooding and erosion. It should be noted that depressions and cyclones can occur independently of global warming and sea level increases. However, there is substantial evidence suggesting that global warming will amplify the risks faced by coastal regions. According to the Intergovernmental Panel on Climate Change, IPCC, in 2014, the following key findings were highlighted in relation to flooding. Sea levels. There is a high level of confidence that sea levels will rise between 28 and 98 centimetres by the year 2100, with the most probable estimate being an increase of 55 centimetres. Delta flooding. There is a high level of confidence that the world's major deltas, which are already at risk of coastal flooding, are likely to face a 50% increase in risk. Wind and waves. There is evidence with a moderate level of confidence indicating increased wind speeds and a greater occurrence of large waves. Coastal erosion. There is a moderate level of confidence that coastal erosion will intensify due to the combined effects of changes in weather patterns and rising sea levels. Tropical cyclones. There is a low level of confidence regarding any notable changes in the frequency of tropical cyclones. However, it is likely that more severe storms will occur. Storm surges. There is a low level of confidence indicating that storm surges associated with depressions are becoming more common. In summary, while the precise impacts may vary, there are indicators that global warming and rising sea levels will heighten the risks faced by coastal areas, including increased flooding, erosion, stronger wind speeds, and larger waves. Occurrence of flash floods. When an area receives a greater amount of rainfall than the ground can absorb, or when the precipitation falls on surfaces such as concrete and asphalt that impede absorption, the excess water has limited place to go, leading to a swift rise in water levels. If the soil is already saturated from recent rainfall, it becomes incapable of absorbing additional water. Conversely, during a drought, the soil may be too dry and compacted to effectively absorb the precipitation. Flash floods are frequently observed in desert landscapes following heavy rainfalls, as well as in areas where shallow soil depth rests above solid bedrock, restricting the soil's ability to absorb. Due to the natural flow of water downhill, rainfall seeks the lowest point along its potential path. In urban areas, this often occurs as flooding in streets, parking lots, and basements located in low-lying zones. In rural regions with steep terrain, flash flooding can transform creeks and rivers into raging torrents. Despite efforts by weather forecasters and emergency personnel to issue warnings and prepare communities, flash floods often catch people off guard. These events have the potential to wash away vehicles and even displace buildings from their foundations. If a levee or dam is overtopped or experiences damage or compromise, it can also result in catastrophic flash flooding. Such situations involve a sudden and substantial release of water, often occurring with minimal warning. The rapid surge of water can submerge entire towns, presenting a severe threat to the lives of residents. Impact of floods. Floods affect people and communities in many ways: social, economic, and environmental. Their impact depends on factors like location, duration, depth, and speed of flooding, as well as how vulnerable the affected area is. Key factors that increase vulnerability to floods include poverty and unequal wealth distribution, rapid and unplanned urban growth, climate change and unstable weather, poor management of natural resources, lack of disaster risk awareness, limited access to technology, weak environmental regulations, overuse of natural resources, disease outbreaks, social factors like ethnicity, religion, gender, age, and health. Positive and negative effects of floods. Floods can bring both benefits and serious harm. Let's start with the positive effects. In many rural areas, seasonal floods support local life. They help with transportation, fish migration, and soil fertility. Other benefits include making land fertile, adding nutrients to seas, clearing debris, supplying sediment to deltas, recharging groundwater, supporting wetland ecosystems. Now, the negative effects. Floods are among the most costly and dangerous disasters. They harm individuals, communities, and the environment. Some major impacts are infrastructure damage, economic losses, loss of life and social disruption, erosion, disease spread, algal blooms. Environmental impacts of floods. Floods can significantly affect the natural environment in several ways. Sedimentation and erosion. Floodwater reshapes the land by eroding riverbanks and collapsing them. As it flows, it carries away materials, suspending sediment in the water. This lowers water quality and may cause harmful algal blooms. Transport of contamination. Floodwater often carries pollutants like pesticides, industrial chemicals, and sewage. When it flows into oceans, it harms water quality and disrupts sensitive ecosystems, such as coral reefs. Spreading diseases. Floods can trigger outbreaks of waterborne diseases like hepatitis A and cholera. They're a major cause of infection after heavy rainfall events. Harmful effect on wildlife. Flooding negatively impacts wildlife. It can cause drowning, increase the spread of diseases, and destroy animal habitats. Social impacts of floods. Floods deeply affect communities and individuals. Here are the main social impacts. Loss of lives and property. Flash floods cause sudden deaths, destroy homes, livestock, crops, and vital services. Psychosocial consequences. Emotional trauma, stress, and long-term psychological effects are common, especially after losing loved ones or homes. Mass migration. Floods force people to leave their homes, leading to urban overcrowding and social tension. Political implications. Poor disaster response can lead to public dissatisfaction, mistrust in authorities, and even regional instability. Economic impacts of floods. The loss of livelihoods. Floods can damage vital infrastructure like power plants, roads, and bridges, causing serious disruptions in economic activities. This can lead to dislocation, loss of jobs in sectors like agriculture and industry, and affect surrounding areas as well. The decreased ability to purchase and produce goods and services. Floods can interrupt access to essential services such as clean water, electricity, education, and healthcare. The resulting decline in purchasing power and land value increases vulnerability and reduces production. Economic growth and development. High costs related to relief and recovery may reduce investments in infrastructure and development. Recurring floods discourage long-term investments and may weaken the region's economic stability, leading to inflation and delays in development programs. Now, let's test your understanding. Which of the following is not a cause of flooding? Forestation, water run of more than convenience capacity, drainage congestion, rise of sea level due to the wind, global climate change. The correct answer is forestation. Unlike the others, forestation actually helps prevent floods, not cause them. This slide presents some of the most catastrophic flood disasters in history, covering events from the 14th to the 20th century. It lists floods that occurred in places like China, the USA, and Northern Europe, along with their causes, such as dam breaks, tropical cyclones, or storm tides, and the devastating consequences they led to. Some of these disasters caused hundreds of thousands of deaths, destruction of millions of homes, and even widespread disease outbreaks. For example, the 1931 Yangtze Huai floods in China caused up to 2 million deaths, and the 1887 Yellow River flood alone resulted in 930,000 fatalities. This table highlights how severely floods can impact human lives, infrastructure, and economies, reminding us why flood preparedness is so crucial today. Before continuing to the next unit, it's time to test your knowledge on Unit 1, Occurrence and Impact of Floods. This self-assessment includes 5 questions based on what you've just learned. Your results will help you understand which areas you've mastered and which ones may need a little more review. So, ready to challenge yourself a bit? Click the button and let's begin the test. You've just completed Module 1 of the Ready for Disaster project, Resilient Communities Through Awareness and Preparedness Against the Risks of Fire, Flood, and Landslide. This initiative is funded by the Erasmus Plus program of the European Union and supported by the Turkish National Agency. Please note, the European Commission and the Turkish National Agency cannot be held responsible for how this information is used. For more, visit our website.